Today in lesson 5, we're going to look at radical equations and solving radical equations. So when we're looking at equations, we're generally looking at variables x under our radical sign, and we're looking for how we can solve what that value of x could potentially be equal to. And with the radical equation, it's any equation that contains a radical. And so the value of the variable which satisfies the equation is called the root of the equation. So here would be my root of my equation for whatever value satisfies the value of x. In this lesson, we're going to solve these equations by graphing them, but also by solving them algebraically. And so for this first one, we want to solve this algebraically. And recall that if we're solving a radical equation or a value for a radical, especially with the square root, we can't have any negative values in our square root. And to solve this algebraically, what we need to do is use inequalities. And so x minus 2, instead of saying square root of x minus 2, in order to solve my restrictions here, I'd have to set this as greater than or equal to 1. Or sorry, not 1, but 0. And then I would solve for this value, and if I bring this to the other side, I would have x has to be greater than or equal to, positive 2. I add 2 to both sides. And the reason x has to be greater than or equal to positive 2 is because if I put any value that is less than 2 under my radical sign, so as an example, let's put 1 minus 2 is equal to 1. Well, if I have 1 subtract 2, I'm left with negative 1. That does not equal 1 because this is going to be a non-real number. We can't take the square root of a negative number. So I know that any value of x I choose in order to satisfy this equation has to be greater than 2 or equal to 2. And so likewise, I would solve this next one by saying 4x plus 1 is greater than or equal to 0. Solving for the root of my equation, or my 0 of my equation. I would solve by going 4x is greater than or equal to negative 1. And then I would divide by 4, and x is going to be equal to or greater than negative a quarter. Now, with our restrictions, we're only looking at the restrictions under the radical sign, so I can ignore the 7 here. And this is going to leave me with 2 minus 5x has to be greater than or equal to 0. And if I bring my 2 to the other side, I'm left with negative 5x is greater than or equal to negative 2. Divide both sides by negative 5. I get x. Now, when we divide by a negative number across my inequality, this actually flips my inequality to the other side. So x is going to be less than or greater to positive 2/5. And for my last one, I have a cube root. And with cube roots, there are no restrictions. So we can have negative numbers in there, and that can yield a real value. So as I said earlier, we're going to be solving these equations graphically as well, and we're going to be doing that with our graphing calculator. And before we start, we want to make sure that we're in our standard graph mode. So go to Zoom and press option 6 for my standard graph. And we want to graph this equation. And so in order to graph this, I would choose my y equals, and I would put in the square root of x plus 1. And I'd close that bracket. And in y2, I would put 4. And now I can graph. My graph is going to look something like this, where 4 is my value that's going straight across, and my value, and if we look at these window settings here, our window settings go from negative 3 all the way to 21. So let's change our window settings here. So our x min is going to be negative 3, and our x max we're going to make 20. And our y max and min will make positive 5 and negative 5. And then we can see where the intersection point is for our graph. So it's going to be somewhere around here. And what we want to do is we want to use our trace function. And so our trace function, second option, and then I would look for my my intersection point, and I gotta choose both curves, and then I gotta guess where I think that intersects. I'm just gonna guess around there, and it tells me that my intersection point is at x equals 15. So I know that this is where my line is gonna cross, and I know it's gonna be around here somewhere. So like that. So that's where I intersect. So we know it intersects at y equals 4, but it also intersects at x equals 15. So in our intersection feature, we used our trace. We used our trace function. So use trace function and trace intersect function. And then we changed our window settings to what they had here. And we want to see the solution to our equation. The solution is that intersection at x equals 15. So right here, x equals 15. And that's what we found in our calculator, x equals 15. Now we also want to state the values of x for which the radical equation is defined. And this is what we did earlier. If I have x plus 1 is greater than or equal to 0, then I know that x has to be greater than or equal to -1. So that's a huge range of numbers, but specifically we get 15, which is a solution. Now we want to verify whether or not this solution is true. And so in order to do that, I just write my original equation. The square root of x plus 1 is equal to 4. And then I substitute my value for x into my equation. So 15 plus 1 equals 4. And I know that square root of 15 plus 1 is square root of 16, so 4 equals 4. All right, so I'll do the first investigation, and the first investigation here will show how we solve these algebraically. So, solving radical equations algebraically, first thing we did was we solved it graphically down here, but now if we don't solve it graphically, what does that look like in order for solving for x? So x plus 1, square root of x plus 1 equals 4. But the first thing I want to do is square both sides. If I square both sides, I'm going to get rid of my radical sign on this side. This is going to be leaving me with x plus 1 is equal to 4 squared, which is 16. In order to solve for x on both sides, I got to subtract 1. This is going to leave me with x is equal to 15. And again, we can verify our solution, which was exactly the same as the equation we had earlier. 15 plus 1 is equal to 4. Square root of 15 plus 1 is square root of 16, and that's 4, which equals 4. Now let's do this next. We'll do this next one as well, just because it is a little bit different. But if I square both sides, square this side, I'll be left with x minus 1. If I square this side, I'm going to be left with a trinomial, but it's going to be x minus 3 times x minus 3, right? So I can write it this under here, and we could use our FOIL method, or the shortcut here is I'm squaring this, I double these two terms, multiply those terms and double them, and then I square the last term. So that would be with x squared minus 6x plus 9. And I haven't solved for x yet, but in order to get this x by itself, I have to get everything by itself, and so I'm going to subtract x from both sides and add the 1 to both sides as well. So this is going to leave me with 0 over here. X squared, negative 6x minus x is going to be negative 7x, and positive 9 plus 1 is going to be plus 10. Now, we got to reach back to grade 10 math when we were factoring. When we're factoring, remember, I want something to be left as a binomial. So when we factor trinomials, we put it into a binomial. And we use that riddle. We could use the riddle method as what multiplies give me positive 10, but adds give me a negative 7. And so what we're going to find is we have two values of x. We're going to have x minus 5, so negative 5 times -2, which is going to be -5 plus -2, and x minus 2, which is equal to 0. And this gives me my values of x. So x equals 5 and x equals 2. Now only one of these is the solution. And in order to determine what the solution is going to be, we could determine what the restrictions on the variable are going to be as well. So if my restrictions are x minus, or root x minus 1, then I know that x minus 1 has to be greater than or equal to 0, and x has to be greater than or equal to positive 1. Well, both these are greater than positive 1. So which one is it going to be? Well, this is where we got to verify the solution. And so in verifying the solution, what you'll find is, well, 3 plus, let's go 5 minus 1 is equal to 5. So 3 plus the root of 4 equals 5. 3 plus 2 equals 5, and 5 equals 5. So that's true. That means x equals 5 is a solution. So let's see if, sometimes you can have more than one solution, and then let's see if 2 is a solution. So if we verify this, 3 plus root 2 minus 1 equals 2. So 3 plus 0 equals 2, or sorry, 1. 3 plus square root of 1 is 1 equals 2. Well, this is 4, and that does not equal 2, so that means the only solution is x equals 5.